Hello sir, myself Hemaprakash and he is Jay Surya and this is Harish Kevin. Our project title is Real-Time Currency Detection System for Visually Impaired People. Our abstract of the project is visually impaired individuals in India face significant challenges in accurately identifying currency dominance during daily transaction. While Indian currency notes are designed with embossed tactile symbols to aid recognition, these features often wear out over time, making them ineffective. This project proposes a smart wearable device in the form of eyeglasses specifically designed to address this issue by leveraging computer vision and audio feedback technology. The proposed system consists of a compact camera mounted on the eyeglasses to capture images of currency notes, a microcontroller that processes the captured image using advanced image comparison and machine learning techniques, and a speaker that audibly announces the identified dominance. The device is designed to recognize Indian currency notes even when they are damaged, crumbled or faded, including dominance such as 10 rupees, 20 rupees, 50 rupees like this. This solution aims to provide an efficient, reliable and portable tool that enhances financial independence for visually impaired individuals. And the introduction of our project is visually impaired individuals face numerous challenges in their daily life, which is the identification of currency dominance. In India, currency notes are embedded with tactile features such as embossed symbols to aid visually impaired users. However, these tactile marks often wear out due to prolonged use, rendering them ineffective. Additionally, notes that are solid, torn and folded further complicate the identification process, leaving individuals reliant on others for assistance. This independency not only hampers their financial independence but also affects their confidence in handling monetary transactions. Existing solutions to this problem include smartphone application and manual tactile recognition methods. Smartphone application utilize optical character recognition or image processing techniques to identify currency, but these solutions have limitations.
Talk about software and hardware requirement. Software requirement to implement the real-time currency detection system for visually impaired people. The following software components are required to ensure proper the factorials, accuracy and effectiveness. Deep learning for framework, TensorFlow and carries and the external framework for training and development to deep learning. Used to model currency regression, they provide to the optimized library for neural network. Implement and model time ensure high accuracy and classification. Micro programming support platform is on inter development environment. The support infant system program versions of the microcontroller like ESP32. Its factorial cells code and complement debugging and development for real-time image processing. Audio processing library by text3 text and speed to converse library that ensure the system or provide to audio feedback and visual input user in always the detective currency detection to the speak on the long improve to assemble to use requirement are ESP232 camera module. The ESP232 camera module is a component internet and the system combined Wi-Fi and Bluetooth connection with an onboard camera with service as the primary hardware of capturing image of the Indian currency note with engines of communications of the data processing update. IoT memory services a direct to storage the solutions of relating data necessary and process and upload the currency regression system. The component of storage insert data set including reference image to currency note and pre-trained and machine learning model ensure the system can function augmentative. ERH speaker is lightweight component and audio output device insert of the converts currency detection information audible to the user. It affects and designed to ensure clear and sound delivery.
I am going to talk about definition of problems and the scope of the research works. Problem definition. In India, visually impaired individuals encounter significant difficulties in performing financial transactions due to the inability to reliable distinction between currency denominations. While static symbols are embedded in Indian currency notes to aid recognition, their efficiency diminished over time due to wear and tear. The degradation of those embossed features combined with the challenges posed by solids, thorns, or crumbled notes further complicates currency identification for visually impaired users. Exist solutions such as manually tactile recognition and mobile appliances. Present server limitations, tactile recognition is unreliable, especially when dealing with worn out note, while mobile application require active user engagement, make the inconvenience and time consumption. Additionally, essential assistance may be needed, comparing user independence and increasing the risk of financial fraud or errors. And the architectural design is we propose the system in the wearable currency detection device to assist visually impaired individuals in identifying Indian currency determinations independently and accurately. Many existing solutions rely on mobile applications or manually tactical identification, while we be considered and ineffectiveness. Especially when we dealing with warm out or solid currency notes, the proposed system addresses the challenges by providing a real-time automated and user-friendly solution that does not require essential assistance. This system integrates a combination of hardware components and intelligent processing techniques to ensure precise currency recognition. The device is lightweighted, wearable in the form of smart glasses and designed for safe use. Our project, the overview of approaches. This study presents the development of robust classification system for Indian currency note, leveraging the ESP32 deep learning architecture. The ESP32 model, renowned for its computational efficiency and high accuracy, was pre-trained on the ImageNet dataset to extract the genetic features and subsequently fine-tuned of recognizing 7 domination like 10 rupees, 20 rupees, 50 rupees, 100 rupees, 200 and like that rupees. Accuracy visualization. The overall accuracy of the model during evaluation is presented in audio output. Despite the training and validation accuracy across the approach, the consistent improvement over approach determine the stable of the training process. Here we see our architectural design. We use ESP32 model to capture the image of the Indian rupees, and the input is once getting. Next it's go to our Arduino processor. It will evaluate and integrate the process which we stored in IoT memory card. We used to pre-trained model in this memory card. With the help of this memory card, we predict what rupees it is, and finally the output is came from the audio output through this speaker.
And here we are going to check our modules working process. I have an Indian currency note which is 100 rupees. I am going to show it in ESP32 module, and it will process by processor, and the speaker will give the output. Here we see how it is. It will tell in 3 cents or something.
100 rupees.
And this is how it is going to be. Thank you. Our conclusion is, in this we developed an innovative currency recognition system using the MobileNet V2 architecture, showcasing the power of deep learning in real-world application. By leveraging a pre-trained model fine-tuned for recognition Indian currency dominance, we demonstrated how computer vision can transform everyday tasks from financial transaction to accessibility for the visually impaired people. While the initial implementation provides a solid foundation, the potential for the further advancements is vast. From miniaturing the system into wearable device like a smart glass to optimizing it for a real-time edge-based operation, the future holds immense promise. As the system evolves in ability to recognize multiple currencies, handle challenging inputs, and operate in energy-efficient portable formats will redefine how we interact with currency in our daily life. Thank you.